Okay. So original time is 40 minutes. Now, how you calculate this 10 minute? Otherwise, if you take the reverse, this is the usual time. Now, this is something which you know. Imagine this is something which you know. If you need to calculate this, 4 by 5 is the speed now. That means 1 by 5 reduction. What will happen? 1 by 4 increase in time. 1 by 4 increase in time will happen from this. So what is 1 by 4 of 40? 10. That is what you got here. Okay, but you don't want to get into all those things. As soon as you see this, now guys, what I will do here, imagine that I am solving this question. I saw this 1 by 5 decrease in time. I know 1 by 4 increase in decrease. This is decrease in speed, so increase in time. 1 by 4 increase in time was given as 10 minutes. So take this 4 here. I got 40 minutes as the answer. Anyone didn't understood this one? This concept? Okay, now let me ask you one more thing. Instead of rate of sugar, I can easily ask you 20% increase in speed. What should be the reduction in time such that distance constant? This is similar to 20% increase in rate of sugar. What should be the reduction in consumption such that what is constant? Expenditure constant. Guys, both are similar questions. Do you think the answer will be different in both cases? Answer is same. Here also, in both cases, answer is same. Similarly, I can ask you 20% increase in efficiency. What should be the reduction in time such that the work is same? Okay. Answer is same. 1 by 6 reduction will be there. Like suppose I used to take 100 days to complete a work. They can give you 100 days. You used to take 100 days to complete a work. Now what happened? You want to finish it early. So what you did? You increased 20% more workers. Okay. Now they will ask you, since 20% more workers are added, in how many days you can finish the work now? Earlier you will take 100 days. Now how many days you will take? 16.6% less days. Ujjwal, how can it be 116? It should be less. Time will reduce because the efficiency is more now. You are increasing efficiency by adding more people. So time taken will come down. So 16.6% will come down. What is 16.6 of 100 days? 16.6 itself. That means now you will complete the work in 83.3 days. Guys, at this point of time, it may look slightly difficult because I'm not directly interacting with you, but still, if you look into this, once the session is over, there's going to be very easy concept, and imagine how many questions you can frame with this concept. If I am an examiner, I don't want any new concept to make question. I can make question from each and every topic in different dimensions. Time and work, there's a question, right? 20% increase in workers. Guys, the way I can put a question is like this. Okay, at the present stage, at the present number of workers, in this situation, there's a question. At the present stage, with the current number of employees, I can finish the work in 50 days. But the contractor want to complete this work earlier, so he added 20% more workers to complete the work faster. Now, in how many days he can complete the work? That is the question. This is going to be a very good question, right? So what he did, 20% added. You don't know what is that 20% or anything. So 20% workers are added. So what will happen with the days? The days taken will come down because more workers, working time will come down. Now 20% is added means what? 1 by 5 increase. So how much decrease will be there? 1 by 6 decrease. What is 1 by 6? 16.6. 16.6% of 50. Or you don't want to take it percentage. You can simply take 1 by 6 of 50. What is 1 by 6 of 50? That is what directly you can take. What is 1 by 3 of 50? Or what is 1 by 6 of 100? You know 16.6. 1 by 6 of 100 is 16.6. What is 1 by 6 of 50? 8.3. So what will happen with this 20% increase of worker, 8.3 days less you will take. 8.3 days less you will take. Since you increase 20% workers, you are able to reduce 8.3 days. That means now the work can be completed in 41.7 days. Okay? Clear or not? Guys, this is how they can make the questions. Okay. Similarly, there is no point in now discussing the length is increased by 20%. What should be the reduction in breadth such that area constant? Okay. So all these can be the questions they can ask you. The only thing is that you need to relate it. Now onwards, what you need to do, guys, as soon as you see this increase decrease story, jump onto it. This is the concept that you need to apply. Get the answer, get out of it. No need to think of anything. Wherever you see increase decrease stories, this is going to be your answer. This is going to be the method in which you need to solve. At least as soon as you see this concept of increase and decrease, jump onto it, think in this dimension, you will be ending up with getting the answer. Okay, now I'll give you a slightly tougher question, and with this question you will really, but I don't think that they will ask you this kind of questions and in CSAT. But I'll give you one question. Let's suppose you need to travel from home to office. Okay, so if you travel at let's say if you travel at 4 km/h, you are 20 minutes late. Okay, so you're 20 minutes late if you travel at 4 km/h. So this is your home, this is your office. Now when you reach the office, you are late, so you want to come early. What you will do, what you can do now, you need to increase the speed. So what you did is you increase the speed to 6 km/h. Okay, now what happened, you are 10 minutes early. Guys, I can make a lot of questions with this scenario. There's a very good scenario. N number of questions I can make. Mainly 5 questions. I will discuss all the 5 possibilities also. So 4 km/h, 20 minutes late. If you increase to 6 km/h, 10 minutes early. Okay. What should be the question here? I can ask you many questions, but I'll take the most difficult one. What is the distance? This distance between home to office is what I need to find out. Guys, what is this distance? Distance is equal to speed into time. 240 kilometer. 240 kilometer, Ujjwal, you will travel with 4 km/h. Then there is no question of 20 minutes late or anything. If imagine 240 kilometer, you're traveling at 4 km/h, how long you will take? 60 hours you will take. Then what is the question of this 20 minutes late or anything? Who's talking about this 180 kilometer? Guys, which logic you are using? Distance is equal to speed into time. Okay, so that is a formula that you need to use. Do you know the speed? Yes, I know this speed, I know this speed. What I need to know? Time. Either I should get time taken in this case, or I should get time taken in this case. Let's take it as scenario 1, and this is scenario 2. Okay, so I know the speed 1, I know the speed 2. Okay, any of the speed I can use to get the answer, provided I need to get the corresponding time. Correct? I hope you are with me now. Distance is equal to speed into time. So S1 I know, if I can get T1, the time taken here, I can get the answer. Similarly, S2 I know, if I get T2, the time taken in this case, I can get the answer. Any one of this is enough, guys. Either T1 or T2 is enough for us to get the answer. Now, guys, they can also ask you this as a question. What is the time taken in the first case? What is the time taken in the second case? These are also potential questions. In fact, I can list out the question which they can ask you. First question, what they can ask you? Time taken in the first case, T1. Second question, what I can ask you? Time taken in the second case. That means when you travel at 6 km/h, what is the time taken? You got 2 questions. And the third is what now they have asked, distance. If I get T1, if I get T2, I can get distance easily, right? Either 4 into T1 I can get, or 6 into T2 I can get. Distance anyway is not going to change also. Okay, so these are 3 questions. Can I frame any other question? 4th question or 5th question I can make? I can make, you think logically, what else I can make? Listen here, here you are 20-minute late, here you are 10-minute early. I can give you a question, what should be the time? Here T1, how much time you took in the first case? Here T2, how much time you took in the second case? I can ask you about a T3. What should be that question, guys? If you take T1, you are 20 late. If you take T2, you are 10 late. What question I can ask you on T3? I can ask you a question on T3 where you reach exactly in the time without being late or early. That means how much time you can take to reach the office without being late or early. That is your T3. Guys, T3, T4, T5, T6, so many questions I can make. I'm not concerned. Like 5 minute early, 10 minute late, 25-minute late. Now you are 20-minute late, reduce it to 10-minute late or 5-minute late. These are different questions. I'm not getting into that. But T3, if I can ask you T3, you can see here S1, T1, S2, T2. What? One more question which I can ask you here. I can ask you S3. What is that? The speed in which you need to travel so that you will reach office exactly at the same time. You travel at this speed, you are late. You travel at this speed, you are early. So what should be that speed, S3, in which you need to travel so that you will reach exactly at the same time? Then S4, S5, S6, I can make many cases like you are 10-minute late, you are 5-minute early, but I'm not concerned about that. These are standard 5 questions. And trust me, these are the only 5 questions which any examiner can ever make in any aptitude exam. If you know that, and if you get to know how you're going to solve it, without using formula or anything, by using the simple concept that you have learned, you're done. Okay, so I'll show you, understand, and then apply it in different scenario. We don't have enough time to practice questions. It's a simple webinar. We will have a discussion maybe after the question paper also. Okay. So guys, what happened here? Speed increase. Let's take the first case. Let's start with time 1. Okay. Or distance also we can find directly, but we can't go directly without finding either time 1 or time 2. We need any one of this to find the distance. So let's find T1. Okay, let's take this as a first case. This is the original case. This is a second case. Okay, so let's take it as original time, and this is a new time. Because this is a first case, original case. Second case, new time. Okay. So 4 km per hour to 6 km per hour. What is the increase? Now you guys can directly tell me 50%. 4 to 6. Guys, how to find the percentage faster? Then that also I'll tell you. Here 4 to 6. What you need to do is see the factor of multiplication here. 4 into what is 6? 1.5. Correct? Minus 1. What is that? 0.5. Into 100. Add 2 zeros. 50. That is your answer. Find percentage. Like that, I think you might not have understood. Let's take this one. 2 to 4. What is the factor of multiplication? What into 2 will give you 4? 2 into 2, right? So 2. Okay, so this is a factor of multiplication. Or 4 divided by what will give you 2? 2, right? That is what you mean by factor of multiplication. Once you know that, what do you need to do? Minus 1. What is that 1? Add 2 zeros. This is your percentage change. Okay, like 100 to 700. For factor of multiplication, 7. Clear? What do you need to do now? Minus 1. What do you get? 6. What do you need to do now? Add 2 zeros. 600% changes there. 300 to 2700. What is the factor of multiplication? 9. What do you need to do now? 9 minus 1. What is that? 8. Add 2 zeros. 800% changes there. Okay. 6 to 9. What is the factor of multiplication? 1.5. 6 into 1.5 is 9. 3 by 2. Okay. So 1.5 minus 1.5. Add 2 zeros. With 0.5, when you add the first zero, it becomes 5. Second zero, 50%. Clear? Guys, this is nothing but your formula only. Final value minus initial value divided by initial value into 100. What is this? This one. Factor of multiplication when I say. It is this one, right? This part. And then adding 0 is this part. You just split this. You have a common denominator. What you can do? Final value divided by initial value minus initial value by initial value. That is what 1, right? Into 100. This is a formula that you have. So when I use this word factor of multiplication, this 2, what is that? Final 4 divided by 2. That is what factor of multiplication. Minus 1. This minus 1. Add 2 zeros. This one. So effectively you are using the formula, but just I used to do in this way, things will be easy for me. So that is why I've told you, take it in that way, things will be easy for you. Okay. So here, okay. So I hope you are with me now. We have the change in speed 4 to 6. That is, either you can take it as 4 to 6. There is a 2 change on top of 4. That will be 1 by 2. Or directly you can write how much? 50% change. 50% is again 1 by 2. So 1 by 2 increase will lead to how much decrease, guys? 1 by 2 increase. The other one will decrease. How much? 1 by 3. Correct? So 1 by 3 decrease will be there in the other. Okay. 1 by 3 decrease means from this time, there will be a decrease of 1 by 3 for this time. Why? Because speed is increased. But we neither don't know this, nor we know this one. Correct? So what we can use from this. First case, 20 minutes late. Second case, 10 minutes early. Look at the change. Suppose you need to reach the office at 10 a.m. First case, when you're reaching at 10:20. Second case, when you're reaching at 9:50. So from here, can you tell me the change? What is the change happened in time? 10:20 to 9:50. Time change is 30 minutes. Why? This 20 minutes late recovered and gained 10 more minutes. So what is the total change in time? 30 minutes. How that happened? 4 to 6 speed is increased. 1 by 2 speed increased. 1 by 3 time will decrease, and 1 by 3 time will decrease from T1, which is given as 30 minutes. I don't know how many of you understood this one. If you understood this one, the case is over. How many of you didn't understood how I got this 30? Guys, I'm talking about there is a clear-cut case of increase in speed. I hope all of you understood that. 4 to 6 increase in speed. So what will happen with time? Time will decrease. Now, can you understand from this case how much time decreased? Two cases are given, 20 minutes late, 10 minutes early. From here, we need to know how much time changed. How much time changed? 30 minutes is the time change. Correct? Because that 20 minutes recovered and 10 minutes overcame, gained. So 30 minute time change is there. So 1 by 3 of first case is what? 30 minutes. So what is the first case? T1, 90. You take this 3 here. So here, this one, first case, time is 90 minutes. What does that mean? If you travel at 4 km/h, you take 90 minutes. Okay? You take 90 minutes. Now, can you get the answer for distance now? Easy, right? We know the formula, distance equal to speed into time. Speed we know 4, time we know 90. So what is your answer? 4 into 90 minutes. This is in km/h. 90 by 60. So you get 6 km as the distance. If you want, you can find the distance by using T2 also. How can you find that? If this is 90, second case, T2 will be 30 minutes less. Right? So T2 will be 60 minutes. Because first case is 90, second case 30 minutes less. So that is 60 minutes. Why 30 minutes less? That we can get from here. Okay, so that will be 60 minutes. Now you can find the distance by using this also, like 6 into 60 by 60, which is equal to 6 kilometers. You see, distance will not change. What will change? Speed will change, like the speed changed. Time will change based on the speed change, but distance remain the same. Okay, so this I got as 90, this I got as 60, this I got as 6 kilometers. What should be T3? What is that question, guys? T3, how much time you can take to reach the office without being late or early? If you take 90 minutes, you are 20 late. If you take 60 minutes, you are 10 early. So how much time you can take? Either you do 90 minus 20 or you do 60 plus 10, that is 70 minutes. That is what you can take. That is T3. Now what about S3, speed? The speed in which you can travel so that you will reach the office without being late or early. What is speed? Speed equal to distance by time. What is the distance? We know 6 kilometers. What is the time that you can take here? If you take 90, you will get the answer as 4. If you take 60, you will get the answer as 6. What we need? We need to take this T3, that is 70. So you will get between 4 and 6. Guys, I know this is at a higher level, but this much is not important for you. But I've just demonstrated the concept and what you need to know. A, B equal to C. If anything is increasing, A or B increase by 1 by X, the other will decrease. How much? 1 by X plus 1. If something is decreased, the other will increase. How much? 1 by X minus 1. This is the only thing that you need to know. And based on this, we will solve questions. Okay. So guys, what I'll do is I'll go to some important other concepts now. This I'm done. So we'll take a 10-minute break and then we will resume at 8:45. Okay. So we will take a break and we'll resume at 8:45. Come back at 8:45, guys.